Hi everyone, myself Pasit. I am from JNTUA CEA from CSC department. Today topic I'm going to explain is a brief introduction to hashing and hash functions. As we know, in future the data will accessing of data will be increased rapidly. So we have to maintain efficient data structure to make sure there is no error in the accessing of data. Normally we use different data structures to access the required data. This is another type of function, another type of data structure to access the data. As for the required data for the large data sets in an efficient way, we are using the different data structures is hashing. I will explain you a term called key. A key can be a type of data structure like string. Basically, key is nothing but it is the input to the hash function. Later we'll see on the key. Hash function. Hash function is a special function that takes input called key and it converts a fixed integer value, usually hash code, we call it, or hash value. This value is determined the index of in hash table where the data will be stored. Good hash function distribute key uniformly across the table to minimize collisions and it ensures the fastest data accessing. And here we are going to see about example of hash table. See, we can see the components of hashing. There will be key 1, key 2, key 3. So, the key is a set and another set is hash function and another set is hash table. Here we can see input is given by the key and it goes to the hash function and it stores in the key index value and value 1, value 2, value 3 in hash table. Okay. Let us see example of hash table in practical. Basically, it maps key to the data using special functions called hash functions. Let us see. Here we can see example h of x equals to x mod of 5. Here x is the value which we give it. In the table we can see input is given 5 and here 5 mod 5 is in the key we can see it has 0. So this is the index values. 16 mod 5 is 1 and 28 mod 5 is 3, 34 mod 5 is 4, 42 mod 5 is 2. Okay, let's move. By hash table, we get values for the index. Okay, let us see. In the previous slide, as we oh we can't. Okay, let us continue from here. In the index 0, the value stored is 5. In the index 1, the value stored is 16. And in index 3, the value stored is 28. And index 4, 34. Further, it goes on. Hash function. Uh, Let us see the hash function. It is a function to convert the given numeric or mixed key integer values. The given integer value treated like index, as we seen in the previous slide. The key value is treated as something index. Each mapping key is given object that can be calculated using function. This is categorized in four types. First one, as we can see, division method. Second one is the mid square method. Third one is the folding method. Fourth one is a multiplication method. Let us see the method by method. First, we will see the division method. The division method is one of the simplest and most commonly used methods to create a hash function. As you can see, it tells us it is the simplest method to create a hash function. The formula is given by hash of key equals to mod of table size. In the previous slide, we have seen the table format. In that table is nothing but it is a division method. Okay, here are the data values. Key equals to 50, 50 mod 7 equals to 1, key mod 7 equals to, uh, it is nothing but key of mod m equals to size of the hash table. As we can see, everything is mod by 7. It means it is the size of the hash table. So for 700, 700 mod 7 equals to 0, 76 mod 7 equals to 6, 85 mod 7 equals to 1. Here there occurs some collision. Further we'll see later. And second method is a mid-square method. In this method, basically, it has two steps. Let us see in step by step. First, square the value of the key is a square key square. Sorry. Extract the middle digits as the hash value. These two steps are the important to follow this method. Example, here we can see the h of key equals to h of key square. Key equals to 20, and here we can I represented key as k, and k multiplied by k is 20 square, that is 400. H of k equals to 400, we can see, and finally we have to represent h of 20 equals to 400. And digit folding method is the third method in hash functions. The first step, we have to divide the key value into a part. That is, like for a number, we have to divide into different parts like k1, k2, k3, and up to kn. Example, there's a number 21325. You can see the k1 is given as 21, and k2 is 32, k3 is 5. And in this method, we have to simply add the parts of the key. That is k1 plus k2 plus k3. By adding this, we'll obtain the final value as 58. And here h of k equals to 58. I hope this method is finds you easy. And next, finally, the fourth method is multiplication method. A multiplication method is another technique for designing a hash function which works well even if the hash table size is not a prime number. Okay, it says that yeah, it works well even it is not a prime number. So let us see further. Here hash key equals to m into key a mod 1. Here we can see. Uh, First, let us conclude. I will explain the terms of this. Key equals the value to be hashed. M equals to size of the hash table. A equals to constant, which is 0 to 1 in between. Often irrational, like A equals to 0.618033. Mod 1 equals to take the fractional. I mean, we have to take the fractional part in this. Mod floor function which takes the integer part. As we can see, mod 1 takes the fractional part, and this floor function takes the integer part. Here we can see key equals to 1 2 3 4, and as we know, m equals to size of the table, a equals to 0. We know it is a irrational part. Step 1. First, we have to multiply k in times a. That is 1 2 3 4 times 0.618033. So that we will obtain some value. We can see 762. And in step 2, fractional part is 0.894 and triple two. And step 3, you have to follow overall outer part. It means into fractional part. 10 into 0.89, it gives 8.9422. Step 3, take the floor equals to 8. Result, we can see here, a hash index equals to 8. I hope this method finds you easy manner. And here are some of the advantages of the hashing. First advantage is the fast data access, provides constant time complexity, big O of 1 for insertions and deletions. Lookups in the average cases. It is also ideal for applications that need quick data retrieval. Here we can see Data accessing is the here we can do it in a more faster way than usual. And efficient search, it provides an efficient search, faster linear search, big O of n, binary search, big O of log of n in most cases. No need to scan the entire data set. As we know, the linear search will scan the whole data set, but binary search does not search the whole data set. No need for sorted data. Hashing works without requiring data to be stored. It tells that hashing does not work without requiring the data to be stored, saving in the pre-process time. Ideal for it is, as we know, it is used for large data sets. Performs well even with the large volumes of data, commonly used in databases, cakes, and indexing systems. And as we know, there is advantage and disadvantage for everything. Let us see the disadvantage. In the hashing, one of the disadvantages is collision. Two key may hash to the same index. It may cause collision in the hash table. Handling collisions with chaining or address adds complexity to the collision. No order in data. And we can see in our previous slide, there is no order for the tables. Do not maintain the order of the elements. It makes tasks like sorting or finding maximum minimum values inefficient. Fixed size in static hashing. Let us see about this. In static hashing, the table size is fixed. If the table becomes full, the performance drops. As we know, the space complexity increases, the performance drops automatically, and resizing is not straightforward. And we can see uh, this is our assignment to our data structure. And thanks for watching for your valuable time. And don't forget to like, share, and subscribe. And yeah, if you have any doubts and comments, please let me know in the comments. Okay. Uh, myself, Sandu Harshit.